Hello my dear students, welcome back to Learn Physics. In today's topic, we are discussing about kinematics portion in that graph. Last class actually I told you I will be starting relative motion. So before that I thought some more exercise I will do relating to the graph. From the DC Pandey's book only, there's for NEET preparation that in that book some more numericals are, more exercise questions are there relating to that. So I thought I'll do that questions and then move to the relative motion. So first question is, from the displacement time graph, find out the velocity of a moving body. For that, displacement is given here and here time is given and graph is like this. And it is making an angle 30 degree. So we know that from the displacement time graph, how can we find out the velocity? Velocity equals displacement divided by time. Right? So slope of the velocity time graph will give you, slope of displacement time graph will give you velocity. To find out the slope of the graph, we can use tan theta value or we can find out dy by dx. Okay, y-axis divided by x-axis we can take. This is the method to find out the slope of displacement time graph. Right? So here, in this case, see it's a time displacement graph. It's not a displacement time graph. So to find out the velocity, we can take 1 by slope. 1 by slope, that is 1 by tan theta, that is 1 by tan 30 degree. Tan 30 we know it is 1 by root 3. 1 by root 3 will be root 3 meter per second. Okay, this is how we will be finding out. Next is displacement time graph of a particle at time t makes an angle 45 degree with the time axis. A displacement time graph is making, and this is displacement and here it is time. This is making an angle 45 degree with the time axis. Sorry, with the time axis only it is given. So I will mark displacement over here. This is time. It's making an angle 45 degree. Okay, then it makes, after 1 second it makes an angle 60 degree with the time axis. Okay, so here it's making an angle 60 degree. Okay, this one it's 60 degree after 1 second. Okay, so here we will get two velocities. Since the slope is different, velocity is changing. So from here to here velocity remains constant and here to here velocity remain constant. So first initial velocity, how we will find out? Tan theta, tan 45. Tan 45 we know it is 1. And what is V2? V2 will be equal to tan 60. Tan 60 will be equal to root 3. Tan 60 is root 3. Therefore, acceleration we can find out. Acceleration equals change in velocity divided by time. What is the change in velocity? Root 3 minus 1 is the change in velocity divided by time as 1 second. So, the final answer will be root 3 minus 1 meter per second square. Next question is, the graph between displacement and time for a particle moving with uniform acceleration is. Which shape it will be? If an object is moving with uniform acceleration, displacement time, velocity time graph, how it will be if it is under uniform acceleration? It will be a straight line with the see velocity time graph will, so velocity time graph will be like this, right? How about the displacement time graph for a uniform acceleration? It will be like a parabola. It will be in a parabolic shape, either in this shape or in this shape, any one shape we can assume, but it will be parabolic shape. Okay, here next is velocity time graph of a moving object is shown in figure. See, here it is time and here it is velocity and the graph is given like this. Okay, so it's more sharp, steep it is. It's given like this and here it's like that. Okay, here 0, 10 and here it is 20, here it is 30, here it is 40 and here it is 80. Now here 20 and the highest portion is it's 80. Okay, here answer in centimeter per second and time is in seconds. The maximum acceleration. What is the max velocity time graph? Well, from the velocity time graph, how we can find out the acceleration? Acceleration can be found out with the help of slope of the graph. Here, where we are getting the maximum slope, will be having highest acceleration. So here 0 to 20, when it is getting, it is 20 only, but from 30 to 40 when I am considering, it is 20 to 80, it is displaced, and here it is only 10 seconds. And otherwise also, if we are looking into the graph which is more steep over here, this portion is more steep. Right, so here we will be getting the maximum acceleration. So here when we are finding out this value, here what is the change in velocity? And this 60 divided by 10, 20 to 80, right? Velocity time graph only given 20 to, so 6 centimeter per second square. 6 centimeter per second square. This is the maximum acceleration. So here also under uniform acceleration only, but when we are finding out, we will be getting this as 1. Right, dy by dx. It is 20 by 20, it will be 1. Here it is constant velocity, so acceleration will be equal to 0. Here 0 to 40 to 80. In that time, the slope is not that steep. So which is more steep, it will be having more acceleration. Clear? Then next is variation of a particle with the time moving along a straight line as in the illustrated in the adjoining figure. Okay, here time is given and here it is velocity in meter per second, and so that here like this, here it is 10, here it is 20, here 1, here 2, here 3, here it is 4. So here the distance travelled by the particle in 4 seconds is, in 4 seconds, see velocity time graph, from the velocity time graph we should find out the distance travelled. How can we find out from the velocity time graph? Distance travelled can be found out with the help of area under the graph. If it is acceleration, you can take the slope of the graph. In velocity time graph, slope of the graph will give you acceleration and area under the graph will give you displacement. Okay, so here it is asked to find out the distance travelled only. They told to find out. Here area under the graph will give you the distance travelled. So here what is here 1, 2, 3, 4. 4 figures you can consider. First is a triangle. Area of the triangle is half into base into height is 20 plus, then this is a rectangle. So here in the rectangle, length into breadth 20 into 1, 20 into 1. This is a trapezium, half into sum of the parallel sides. So here it is 10 plus 20, that is 30. And perpendicular distance between the parallel sides, that is 1 plus next is 10 into 1. So here you will get it as 10 plus 20 plus 15 plus 10. So here 30, 40, 55 meters. 55 meter is the answer. Yes, it's correct only. So from the velocity, if we are finding out the area under the graph, we will be getting the distance travelled for the velocity time graph. Clear? Next is a lift is going up. The variation in the speed of the lift is as given in the graph. What is the height to which the lift takes the passengers? So here it's given like graph is here velocity is given in meter per second, and here it is time is given in second. 0 to 10, this is 12. Okay, so here it's after then till 10, 10 to 12, it is a steep graph like this. Okay, this is 3.6. Now the variation in the speed of the lift is given. Velocity time graph is given, so the speed, that variation in speed is given like that. What is the height to which the lift takes the what is the height to which the lift takes the passengers? Maximum which height? Height means we should find out the maximum displacement. Okay, so how much we can find out the distance traveled? Here it was moving under uniform acceleration, then with constant velocity, then under retardation. Okay, area under the graph will give you displacement. Area means this lift movement means whether displacement will be happening. No, distance travel we should find out. Okay, so here area under the graph. So here displacement S will be equal to area of trapezium. How we can find out the area of the trapezium? Half into sum of the parallel sides. So this is one parallel side and this is another parallel side. So here it is 12 and here it is 2 to 10, it is 8 into perpendicular distance between the two parallel sides, which is 3.6. So 20 by 2 into 3.6, it will be 36 meter. Okay, S will be equal to 36 meter. Next question is, the velocity time graph of a body moving in a straight line is shown in figure. Displacement and distance travelled by the body in 6 seconds we should find out. So here graph is given. So here we need to find out the displacement and distance travelled. So while looking into the graph, it was moving with a constant velocity. Suddenly the velocity changed to -2 and then velocity increased to +2 and then come to 0. Okay, so here how can we find out the distance travelled? To find out the distance travelled, area under the graph. Area under the graph means here it will be 2 into 4 plus here it is coming for 2 to till 4, so 2 into 2 plus next is 2 into 2. So here we will get it as 8 plus 4 plus 4. So here it is 16 meters. This is the distance travelled. Now we need to find out the displacement. So which is coming with a negative velocity. Velocity is decreasing. Velocity decreasing means displacement by time is velocity. So to find out the displacement, how we can find out the displacement here? Here it is 4 into 2, 8. Then it is -2 into, we should consider the negative sign also. -2 into 2. Next is +2 into 2. So here it is minus, this will be getting cancelled. So displacement we will be getting it as 8 meter only. Clear? So here in the case of displacement we should use the negative symbol also, because displacement is a vector quantity. We should consider that negative sign also. Next is the xt equation is given as x is equal to 2t plus 1. The corresponding vt graph is a straight line passing through the origin, straight line not passing through the origin, a parabola, none of the above. So velocity time graph, if velocity time graph is asked, okay, v is equal to dx by dt. dx by dt will be equal to 2. So velocity is not changing with respect to time. So it will be under uniform velocity. If it is under uniform velocity, the object will be under uniform motion. So it is starting velocity is, it's under 2. So it's moving with a constant velocity only. So it will be, it's a straight line which is not passing through the origin, because it has a, see, velocity time graph. It's asked for velocity time graph, the corresponding velocity time graph. So x is a quantity which is changing with respect to time, but velocity is not changing with respect to time, but it has a constant value at the starting itself. Right? So it is, velocity is a term which is not depending on time. It's a constant velocity, straight line not passing through the origin. Okay, clear? So these are some of the questions relating to this graph questions. Some more are there. So we will be discussing that in the next class. So I think in today's video it's useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.